Hi everyone, welcome back. This is the second video going over the equations of motion test. We're gonna do question 4 now. It says train traveling at 40 meters per second. So my initial velocity is 40 meters per second. When its brakes are applied, this produces a deceleration of 2 meters per second squared. So my acceleration is going to be a negative 2 meters per second squared. Since it's a deceleration, it's going to be negative. Then it says that's all the information that we get. It says how long does the train take to come to rest. So it seems that we only have two variables, but it says that it comes to rest. So therefore in part A we know that v is equal to 0 since it comes to rest. So then we have three things and they ask us for how long, so that's the time. We've got v, u, a, and we want t, so that should be v equals u plus at. We want to get t, so let's move the a and the u. We want to move the u first because it's further away from the t. The u is adding, so it goes to the other side subtracting. We've subtracted u from both sides, and now we want to move the a and leave the t alone. The a and the t, even though you can't see it really, they're multiplying, so the a comes to the other side dividing. So we've divided both sides by a really, and here the difference in velocities v minus u would be, well, v is the final velocity, and since it's coming to stop, we've said here that v is 0 because it's going to end at rest. So that's 0 minus the initial, which is 40, so that's going to be a negative number, divided by minus 2, also negative. So the good thing about this is that the negative divided by a negative is going to give us a positive, because time is a positive. So 40 divided by 2 will be 20 positive, and that will be how many seconds the time is. Hopefully that makes sense. We're going to do part B. Part B says how far does the train travel before stopping. So now they're asking us for the distance s. And as I said before, it's ideal if we don't use the information that we just worked out. It's better if we use what they give us in the question. So we can use this guy here, v is 0, which we know, that we're completely sure about, and that we're completely sure about also. So let's use those three. That would be v, u, and a, and they ask us for the distance, which is t. How far does it travel before stopping? So let me see, u, v, and a, and s. That would be v squared equals u squared plus 2as. Let's check. V, yep. U, yep. A, yes. And we want s. Brilliant. So let's move this around. We want to leave the s alone, so we want to move the 2a and the u. The furthest thing is the u, so let's move the u first, and since it's adding on that side, it's going to come to this side subtracting, and that's what do we have left? V minus u is equal to 2as. Good. Now we can imagine there is a bracket here around the 2a, because the 2 times a times s, they're all multiplying one another, so that's like 2 times a times s. So we could imagine that there are brackets here really, and we can move the whole of the 2a to the other side. And since the 2a is multiplying, it's going to go to the other side dividing. It's the same thing as dividing by 2a on both sides. Here we divide by 2a, there we divide by 2a, and we get a 1. So we might as well, instead of writing 2a 1 times s, we write just the s. So that's what we wanted to find out. We've got v, which is 0, u squared, which is 40 squared, 2a, 2 times 2, but it's minus 2, so that's minus 4. So we've got negative 40 squared at the top. 4 squared is 16, so 40 squared is going to be that with 2 zeros afterwards. And divided by 4, so that's 1000. So that's going to be 1600 divided by 4. Negative over negative is a positive, so that's okay. So our s, I'm going to put it on the left hand side now, but it's the same as this. If 16 divided by 4 is 4, then 1600 divided by 4 is going to be 400. So our distance is 400 for part 4. And the last question in the test was part 5, and it said a stone falls from rest a distance of 45 meters. So from rest means my initial velocity u is 0 meters per second, and the distance they give us is 45 meters. And since it's falling, and the gravity is just falling, we also know the acceleration, which is the one that we're missing, because it looks so we only have 2, but it's falling under gravity. Since there's no air resistance, A is equal to G, which is equal to 10 meters per second squared. Right, and since G is positive, since it's going to be speeding up the velocity, the speed. So here, if we want to find in part A, how long does it take to reach the ground? So we want the time. We've got USA, and we want the, wow, it sounds like United States of America, man. And we want the time, and so we want USA and T, and let's see, T, U, S, and A. V equals, no, V squared equals U squared plus 2AS. No. So when I get stuck, the best thing is to write them down. V equals U plus AT. V squared equals U squared plus 2AS. S equals UT plus half AT squared. I also recommend when you do these questions, you write them all out every single time that you do the question, so that eventually they get stuck in your head and you don't need to do it anymore. But at the beginning it's good to do that. And that's an S, even though it looks like a 5 or something. And the last one, which we don't normally use very much, but it's really useful, you should definitely know it, is that the distance is going to be equal to U plus V over 2, we talked about it before, times T. Right, and here we have, we don't know the V, so that's not useful, and we want the time, and we have the, well, really, this T here is the one we could use, but if we want to find T, this is a really bad idea to use this, because then we have a quadratic, and you guys haven't learned to solve these yet, so it's not good to write T equals whatever. So in this case we're going to have to find V first, and then that will help us to use one of the other equations. So let's use this guy here, which has the S, which we know, and the U and the A in order to find V, and once we know V, we can then use this one, for example, to find the time. So let's do that, and let's do it down here. Okay, so V squared is equal to U squared plus 2AS. So V is going to be the square root of U squared. U is 0 because it starts from rest. 2 times A times S. We said the acceleration was positive because it was in the same direction as the speed. And 2 times A would be 20, and S is 45, so this is 20 times 45. And 20 times 45 comes out to 900. So the square root of 900, which is what we're interested in, if the square root of 9 is 3, then the square root of 900 is going to be 30 meters per second. And that's not the end of the question, because we needed that in order to use another equation to now find the time. But if you look at part B, it says what is its velocity as it hits the ground. So actually we've just solved B, which is the final velocity, and to do A we need to perhaps use this one here, and we've rearranged that. We subtract U from the left because it's on the right it's adding, and then we divide by A. T. It's a very ugly T. That's more beautiful. And so then it would be 30 that we just calculated minus the 0 divided by a, which is 10, that would be equal to our time. So that's 30 divided by 10, which is 3 seconds to hit the ground, is equal to our time. So that was everything. That's everything in the test, and hopefully you've gone through this at home, and any corrections that you needed doing you've been able to do. And if you have any questions, please come to me and let me know. Alright, hopefully that's something you can use. See you in the next video or in the classroom.